Hello class, today we're going to be looking at 6.4, creating equations for direct and partial variations. We've skipped over 6.3 for the sake of time in our course, which was the direct and partial variations. We're going to get a bit of a crash course in that right now. So our first graph here shows a straight line that passes through the origins 0 and 0. So remember that's our x and that's our y points there. And this illustrates a direct variation. So you can see 0 and 0 and it goes up. We've got cost and hours there. And on this side here, we have a straight line that does not pass through the origin, but it starts at an initial value, which is our y-intercept. As we can see, it passes through our y-intercept at 40 in this one, and this illustrates a partial variations. All right, so what does that mean, and how can we write equations for this? All right, so our direct variation, to write an equation, what we need to do is we need to find our rate of change, which we have gone over in our last one, which is our rise over run. Remember, we take 2 points along this line, and then we find our slope, and that's our rate of change. And what we're going to do is we're going to multiply that by our independent variable, and our independent variable is always found at the bottom of the graph. Remember, that's the one that changes, that doesn't get impacted based on the other one. So time will continue on. So in this example, we have C equals 30H for the Hemlock Bluff graph. So that one's there, so 30H. So we found the rate of change, and that's 30, and we multiply that by the hours. And the equations for partial variations, they are longer. We take the dependent variable, which is our cost. That's on our y-intercept. And that is going to equal the rate of change, rise over run. We're going to multiply that by our independent variable, again from our bottom, from our x-axis, and then we are going to add in that initial value. So we see here that our initial value here was 40. That's the first thing. So that means we're paying $40 right off the bat, and then we have a rate that we're paying as we use something, as we use equipment. So for our example, we have C equals 10 hours, or 10H, so 10 times the amount of hours plus $40 for the Big Pine graph. We're going to look at an example here on how we could do that. So Lisa works at a job and she gets paid $12 an hour. Is this partial or direct variation, and why? Well, there's nothing initial, or there's nothing added on like we have here, plus 40. We are seeing that it's just the $12 per hour, so it would be a direct variation, as her earnings are changed based on hours worked and nothing else. Write an equation to represent this this description, and explain what your variables represent. So the first thing we're going to do is when we're creating an equation, we need to have two sides of an equal sign. So we're going to do earnings, so we want to find out how much does she make. So we're going to use a capital E, and we're going to let H represent the number of hours worked. So we have E equals, we see that she gets paid $12 per hour, so we're going to have 12 times the number of hours that she works. And we can use that and find out a lot of information, which we will in just a second. So now, if Lisa works 40 hours, how much does she earn? So we're going to use this equation, E equals 12H. So first thing we're going to do is we're always going to write down our equation first. So E equals 12H. Then we're going to substitute in that she works 40 hours, and we said H equals the number of hours worked. So we're going to substitute that in. So we're going to do 12 times 40, which gives us $480. And then we're going to write a little sentence beside, therefore she will earn $480. D, if Lisa earns $222, how many hours did she work? So now we know how much she's earned. So when we have our E equals 12H, this is our earnings. So we can put our 222 down there, equals, well, we know that she gets paid $12 per hour, but we want to find out how many hours she works, so we don't know H. So we need to get it down to just one H. So if we think back to our algebra unit, we need to take the number that's in front of here, and we see that this would be 12 times H. So we need to do the opposite function, which is division. So we divide it by 12, and we divide the other side by 12. So we have to keep things equal and balanced, and that'll leave us with 18.5 hours. Therefore, she worked 18.5 hours to make $222. All right, going on to our next example, Daniel joins a gym and he is told he needs to pay $100 for the membership and an additional $5 per class he attends. So is this a partial or direct variation, and why? Well, this one would be a partial because he has to pay $5 per class, but he also has to pay an initial fee of $100. So just like on our graph above, there is an initial thing here that would have to be paid. So Daniel would have to pay $100 first, and then every class he goes to would be another $5. Write an equation to represent this description and explain what your variables represent. So we're going to say let C equal the cost. We want to find out how much does Daniel have to pay. So we're going to find out what the total cost is, and we're going to let N represent the number of classes. So we have cost equals, we have $5 per class, so 5N, and then we have to add that initial $100 that he has to pay for his membership fee. So we're going to plus 100, and that won't change off of anything else. It's just a straight $100, so we consider that a constant. If Daniel attends 5 classes, how much will it cost him total? Use the equation to show your work. So again, we have our equation, C equals 5N plus 100. So N, we know that that's the number of classes, and he attends 5 classes. So we have 5 times 5 plus 100. 5 times 5 gives us 25 plus 100. The total cost would be $125. And a sentence to wrap it up. Therefore, it will cost him $125 to attend 5 classes. All right, now let's look at it from the other side. If Daniel spends $195, how many classes can he attend? We're going to, again, use that equation to show our work. So C equals 5N plus 100. So we have the cost equals 5 times the number of classes plus 100. So we know that he spends $195, so that's going to go on the left-hand side over here of the equal sign, and that's going to equal 5N plus 100. And just like in our algebra class, we want to get rid of anything that doesn't have a variable first. So the opposite of plus 100 would be subtract 100. So we take 195 minus 100, gives us 95. So it would be 95 equals 5N. Now again, we want to use the opposite function, and this is 5 times N. So we're going to use division. We're going to divide it by 5. So 95 divided by 5 gives us 19, which means that he can attend 19 different classes. So there's our crash course and our finding equations for direct and partial variations.